Hey everyone, welcome back to the channel where we break down maths questions the easy way. In this quick session, we'll smash 3 classic GCSE questions on sets and Venn diagrams, completing a diagram, reading sets from a diagram, and finding probabilities, including conditional probability. Let's go. Question 1 gives us the universal set containing the numbers 1 till 16. And we're told that set A is multiples of 3 and set B is multiples of 5. Part A asks us to complete the Venn diagram. So the first thing we'll do is we'll take a look at what multiples of 3 and what multiples of 5 we have. Multiples of 3 we have in the set 1 to 16 are as follows. We have numbers 3, 6, 9, 12, and 15. These are the multiples of 3 that we have that are between the numbers 1 and 16. Multiples of 5 that we have in the set are 5, 10, and 15. Now we can look between these and see that the intersection of both sets contains just the number 15, as this is the number that appears in both sets. And the numbers that are only in A are 3, 6, 9, and 12. And the numbers which are only in B are 5 and 10. Using this information, we can complete the Venn diagram for both sets, and then whatever numbers are left over, we can fill on the outside. So in set A and B intersection, we can write the number 15, as this was the number that was in both of the sets. In set A, we have 3, 6, 9, and 12 remaining. And in set B, we have the numbers 5 and 10 left. The numbers from the universal set that are currently not in set A and not in set B, we must put on the outside. This means that the numbers 1, 2, 4, 6, 7, 8, 11, 13, and 14 are outside of the set. But because they're part of our universal set, we must include them in the Venn diagram. So now we've used all the information and we've put all of the numbers of the universal set onto our Venn diagram. This completes part A of completing the Venn diagram. Let's now look at part B. Part B asks us to write down the probability of A intersect B. In other words, when one number is chosen at random from the universal set, what is the probability it lies in both set A and set B? The number of events that are in both A and B is one element, the number 15. And the total number of outcomes is 15. This means that the probability of being in both A and in B is equal to 1/15. And so this would be our answer for part B, 1 out of 15. In other words, if a random number is selected, the probability of it lying in both set A and set B is 1/16. Let's move on to question 2. Question 2 gives us a Venn diagram with sets C and D. And this is a simple question of writing down the numbers that are in the sets that are specified. From the diagram, we can see that the elements in set C only are as follows. 1 and 4. These are the only elements that are in just set C. The elements in set C and in set D, in other words the intersection, are the elements 5 and 9. And the elements in D only are the element 6. As this is the number that's only in D. The elements outside, in other words, elements that are in neither, are the elements 7 and 11. So now that we know where each element is, it will make it easier to answer the question. For example, part A wants us to write the numbers that are in set D. If we look in our list, we can see that the elements in set D are only the number 6. Part B asks us to write the elements that are in C union D, as in anything that's in either circle C or circle D. These are the elements 1, 4, 5, 6, and 9, as these are the ones that are in both set C and set D, which I've highlighted in yellow. Finally, we're asked to find the elements that are not in C, but are still in the universal set. So this means that the elements that are in D only and the outside numbers, which, as we can see from both the diagram and the list we created, include the elements of 6, 7, and 11. And there we go. That's another 3-mark question solved. Let's move on to the last question of this video. We're given a Venn diagram again with sets A and B. This time we're asked what the probability of choosing A and not B. A good way of visualizing this is by shading in the diagram. So the elements in A are highlighted in yellow, as I've just done, and the elements in not B are highlighted in pink. This elements in not B means everything in A and not B and all of the outside elements. As we can see, we're asked for the intersection of both of these events, i.e. the bit that's been shaded both yellow and purple. This means the probability of choosing an element in A and not B is 1 out of the total events. Total number is 7. So the probability of A and not B is 1/7. Now part B asks us to work out the probability of not A or not B. In other words, we want the elements that are not in A and not in B, just the outside elements. Let's start by shading not A. We'll do this in yellow. So that's all of the elements that are just in B and the outside bits. Now let's shade the elements that are not B. These are the elements just in A and the outside bit. We look for where the overlap lies and see that the probability of being not in A or not in B is all of the elements that we've highlighted. So that's a possible 5 out of 7. As there are 5 elements that have been highlighted, the elements 4, 8, 11, 10 and 12. So 5 out of 7 is the probability of being not in A and not in B. For part C, we're asked what's the probability of being in B given we're already in A. So to start off with, we're only considering the elements in A, as that is the set we are working with. This means that any probability will be out of the number of elements in A. This means it will be out of 3, as that's the number of elements in A. Now we also want the probability of being in B. We can highlight the elements in B using blue. But remember, we're only considering the yellow section, so we're only interested in the intersect between A and B. So you can modify your shading as needed. We can now see that out of a possible 3 elements, only 2 are highlighted. So the probability of being in B, given we're in A, is simply 2/3. And that's a taste of conditional probability. Well, there we have it. 3 exam-style questions done. Completing a Venn diagram, reading sets, and calculating probabilities, including a conditional one. If this helped you feel more confident about tackling Venn diagram questions, hit the like button, subscribe for more walkthroughs, and drop a comment below if there's a topic you'd like for me to cover. You've got this. See you in the next video.